In this video lesson, we're going to learn the trigonometric ratios of sum and difference of the two angles. Especially in this video, we're going to learn the cosine of difference of two angle. All right, and that we're going to derive we'll derive as cosine of first angle times cosine of second angle plus sine of first angle times sine of second angle. This we're going to derive, and with the help of this formula we can easily find out the cosine of the sum of two angles. Here A and B are two different angles, all right, and that will get this is actually the result, and we are going to derive these results. We'll get cos of A cos of B minus sine of A times sine of B. So how this formula came, let's take a look, right? How to derive this formula, let's take a look. For that I need to make a unit circle. Let's say I have a circle. This is my rough circle. Hope it's looking good. Really bad circle. Anyways, this is my here x axis, positive x axis, positive y axis. This is my origin, all right, and as I said, this is of unit length, all right. So the radius of this, this is of 1 unit. So 1 unit means the coordinate of this point, let's say p naught, is 1, 0, all right. And now I'm going to imagine a point here. Let's say this is point 1, all right, and this point 1 I'm going to connect with origin, and let's say the point after connecting this point 1, we got a line OP1, and that OP1 radius is making the angle of B with positive x-axis, all right. And we need to find out the coordinate of this point P1. So I'm going to draw a perpendicular here, and after drawing perpendicular, it is looking almost like this, exactly like this, with the angle B. And here this is angle B, so this opposite is the perpendicular, and this is the base, and this will be our hypotenuse. The longest side is always hypotenuse. And if you take a look properly, then cosine of B here is actually the base over the hypotenuse, right? So the base over the hypotenuse, that is B over H. And if you look sine of B, then that's actually the perpendicular over the hypotenuse, right? So perpendicular over the hypotenuse. And let me tell you one thing, my friend, here this B is actually base here, but in this figure B represents our x coordinate of the point P1, all right. This we are going to find out. So this is actually our x coordinate, and similarly in the figure this is P, but in this figure if you look, this is our y coordinate of the point P1, all right. This is our y coordinate. So I already said that this circle is of hypotenuse 1, this hypotenuse 1 saying, or the radius is actually of 1 unit. We have already considered that, all right. So this entire till here or till here, both are hypotenuse, all right, and both have the 1 unit. So simple B is going to be H times cos B, and H is going to be and P is going to be H times sine B. Here this B is representing our x coordinate, which is now H is 1, so it is simply cos B, and this P is representing y, so it is simply sine B, all right, it's B. So finally we got the coordinate of this point P1, that's our cosine of B and sine of B. In the similar manner, let's say we have one more point here, let's say point 2, all right, and let's connect this point 2 with the origin, all right, and let's say the point 2 is making the angle of A with the positive x-axis. So that what we can say, the coordinate of this point P2 is almost same. In the same way we are going to find out that will be our cosine of A and sine of A, right. And now I'm again imagining one more point here, right, point 3, which is actually when after connecting this with origin, which is making angle exactly equal with A difference B, all right. This complete is angle A, all right, this is complete angle B, and this point 3 is actually equal with A difference B. So the coordinate of this will be definitely in the same way. If you look, it will be cosine of A minus B and sine of a minus b. All right, so we got the 3 points. Point 1 making an angle of b, point 2 making an angle of a is angle here bigger and b is a smaller one, and point 3 which is making angle a difference b. All right, and now here I want to tell you one thing, that the angle P3O P0 is equal with angle P2O P0 minus angle P1 O P0. I'm going to say P like this. I'm saying this complete angle is equal with angle B minus angle is equal with angle A minus angle B. All right, so and now this is equal with angle A minus angle B. All right, so both the angles are equal now. This angle and this both angles are equal, so the chord subtended by these two angles will also be equal, right? We had already learned these things in geometry. If the angle like made by the two chords on the central angles is equal, then the chords are also equal. I mean, angles are equal, central angles are equal, then the chords are equal, and if chords are equal, then central angles are equal. So here angles are equal, so we can say the corresponding chords are also equal. So the corresponding chords for the P3O P0 is P3 P0, this chord. All right, this chord. All right, let's say this is P3 P0, and the difference of this angle is actually this one. All right, this particular this is the angle, you know, this complete minus this much is this A minus B. This is also A minus B, so the representing chord is this P1 P2. All right, this is P1 P2. So now we can use the distance formula. Let's use the distance formula to put the values. Now P3 P0. All right, the length of this P3 P0 chord will be x2 minus x1 whole square, under root x2 minus x1, y2 minus y1. We are using distance formula that we had learned, that is x2 minus x1 whole square, this is coordinate, and y2 minus y1 whole square, right, inside the root. So the same thing I'm gonna do here. So our x2 is cosine of a minus b, cosine of a minus b, x2 minus x1 is here 1, right, whole square, plus y2 minus y1, that is sine a minus b, sine a minus b minus 0 whole square. So this is now equal with P1 P2. All right, so P1 P2 we have, yes. So again x2 minus x1, so that is cos a minus cos b whole square, plus again sine a minus sine b whole square. All right, sine a minus sine b whole square, and inside the root. So now let's square both sides. Squaring both sides, we get this root will remove off, and we'll get cos a minus b minus 1 whole square, plus sine square a minus b, and that's it's going to be cos a minus cos b whole square, plus sine a minus sine b whole square. All right, and now let's use the formula of a minus b whole square. So it will be a square minus 2 a b plus b square, and this sine square a minus b, and then here equals to we can use same a minus b whole square formula. So it will be a square minus 2ab, right, minus 2a b plus b square. And now let's do the operation for this sine a minus sine b. Again a square minus 2 a b plus b square, right, this is sine square b. All right, and now see here, many things are going to get a smaller value. This cos square a minus b and sine square a minus b will turn to 1, and this is already 1. All right, and now this minus 2 cos a minus b and equal with now cos square a, and this sine square a will result to 1, because we know actually this I'm using cos square theta plus sine square theta equals to 1. Right, I'm using this identity, so cos square a plus sine square a, that's 1, and again here cos square b plus sine square b, that's going to be 1. All right, and now minus 2 cos a cos b minus 2 sine a sine b. All right, so see here, we can cancel here something. We can cancel this 1 and 1, this plus 1 and this plus 1. All right, and further we can cancel this 2 also, but I'm first writing minus 2 cos a minus b is equal with, now here we can take minus 2 common outside, so minus 2 will come outside, and it will be cos a cos b and then plus sine a times sine b. All right, so it's going to be minus 2 and minus 2 will cancel up, and finally we'll get cos a minus b equals to cos a times cos b plus sine a times sine b. All right, so this is our required identity, or the formula that we were about to find out, and this is how we find it up. So cos a minus b is cos a times cos b plus sine a times sine b. All right, and now we can use this formula to find out this cos a plus b also. How? Let's see here. We have this. All right, let's say here cos a minus of b. All right, now actually I changed the angle, just in the place of the this b I put here minus b, so it's going to be now cosine of a times cosine of minus b, and then plus sine of a times sine of minus b. All right, and now this is cosine of a, and cos, now let me tell you, cos of negative angle is actually cos positive angle. Cos minus theta is actually cos theta, so cos minus b will be simple cos b, and now here this is minus sine b. All right, and one more thing here, minus sine theta is actually minus of sine theta. All right, sine of negative angle is minus sine of that angle. All right, so this minus b it is, so it will be minus, and that minus I'm putting here, and then sine a times sine b. All right, and what is this? Cos a minus of b, this minus plus, so it is a plus b. All right, and this is our cos, and this is how we need to find out cos a plus b. So this is these are the two results, the cosine of difference of two angles and cosine of sum of two angles. So this is how we need to derive the formula. I hope you understand it, and in later videos we're going to do a lot of applications of these two formula, and we're going to find out the other formula also based on this, and with the help of this formula we're going to find out a lot of other trigonometric relationship, trigonometric identities. All right, so see you in the next video. Goodbye.